right. Hope you guys had a good weekend. And can I just say at the start of this video that it's starting to settle in, man. I'm missing you guys, missing being at the school. But anyway, we press on. We do what we can. But this next material that we're going to be moving on, so you should have took your test yesterday. And so that was unit 2. We're going to be moving into a unit. I'd like to do a little unit on statistics. Okay. And this is now, we're going to just be hitting the basics of statistics. There's whole college classes and whole fields that you can go in with just statistics. That's always a fun word to say. But basically, I mean, you could go really deep into this. We're just going to kind of highlight. There's some things that I want to highlight throughout this that I think you could use in your everyday, just normal, just daily interactions with things. That I think it would be beneficial to know the math of it so that you can make, good decisions or realize what's going on. One thing is we can record and organize data or data, have you said data if you're British or something, or data, or if you like the Ozark slang that sometimes comes out dater, but you can organize that in a way that would help you. I think, especially going forward in some of your other classes, you get into a science class, and if you can organize your data in a good way, then it will help you do your homework, make decisions, do the problems. Whether you put it in charts or graphs or however you choose to put that, we're going to go through different ways that you can do that will help you in those fields. Another thing that I think helps, and this is where we're going to actually start, is I think it helps you formulate educated decisions based on that data. But basically, you could go through and when you either organizing it or just finding out the probability, which is where we're going to start of something, it will help you then make decisions based on what you find. If you are running a business, statistics are a huge benefit in the way of looking at how well your business is doing and then making decisions based on that. If you are looking at, well, what's my chances of this happening? What's my chances of preparing for this? Then it will help you make decisions now that will help you in those future times. So I kind of want to start there. Now we are going to get into charts and graphs and some of that later. I think some of it is actually kind of easy once you break it down. The math part of it's not really that hard. It's just understanding how to put it on there and how maybe a chart puts something on there so that you can read the data really quick and be like, oh, I know what they're trying to say. Graphs can be misleading. Polls is another thing. When people say, well, we took a poll and we asked some people this, they can be misleading. Depending, if they asked however many people they asked, they could say 50% of people said this, and they only asked 2 people. And it just sounds like, ooh, 50%. Well, if you only ask 2 people, then the other person just disagreed, So it really can play into, are they misleading? Are they representative of what you're trying to find out? So that's where, I think all this kind of ties together. But I do want to start with probability. And we're just, like I said, you could go really deep into some of these. And probability. What was the probability that I would spell that right? But basically, you could get deep into probability. There's compound things you could do. That, oh, what if this happens and then twist this and change that? We're kind of just going to stay near the basic level so that we get an idea of how to do probability. But basically, it's like, what are the chances? What are the chances of this happening? What's the probable outcome? And we use, when you learn about probability, especially in a high school level, there's some basic ones that we use as an example. Not that you're going to use these in your everyday life, but then you can take the knowledge of it and translate it into what you're doing. Examples, flipping a quarter. You're not going to sit and try to figure out the probability of flipping a quarter in your everyday life. Like, well, what's the chances I flip a head? Or rolling a dice. Now, maybe if you play a game every day, you may want to know that. But at the same time, it's not necessarily that you're going to do that every day, but you can take the knowledge of what we use, like rolling a dice, and apply it to what you're trying to figure out. Another is like drawing a card. We use that as an example. If you are drawing a card out of a deck, you know, what's my chances of drawing an ace or drawing a heart or something like that. So we're going to look at those, rolling a dice, drawing a card, maybe, you know, those kind of things to show what this probability, how to do this. The first thing that I want to put up there is a little formula that we use, and it's not a really hard formula. It's just basically a fraction, which when you hear the word fraction, everybody loves that. But we're just going to put the favorable outcomes over the possible outcomes. Okay, we're going to turn these first ones that we do into this. Favorable outcomes over possible outcomes. Now right now that may not mean much, but you're going to see that's not a hard formula. Basically, it's just going to be one fraction that then we do like we did when we did 3 out of 5 dentist or something like that when we did that on the prior thing. We're just going to divide it and turn it into a percent. But let's start with the rolling of the dice, okay? So let's say I want to roll a dice, okay, and a dice, we're going to talk about just a normal 6-sided dice. It's got 1, 2, 3, 4, 5, 6 on the dice. I know they make bigger ones, but we're going to just do the 6-sided die. Let's say I roll that dice and let's say I'm playing a game now, I really want to get a 5. I'm like, oh man, I'm going to roll, I really want a 5. Okay, what's my chances, and then as a percent, what's my chances of rolling a 5? Okay, and you kind of want to know, is it a 30% chance, a 10% chance, a 100% chance? You know, what's my chances of rolling a 5? What statistics really, what it really does is it takes feelings and guesswork out of it, even though we always know that you know, that's the thing about a percent chance. Yes, you may have a 30 or 40% chance. Well, let me use this example. You flip a quarter, you have a 50% chance it's going to be heads, but you also have that chance it's not going to be heads, it's going to be tails. And I always use, you know, I use my dad's example. We play Yahtzee, and he, you know, he'll roll and he'll start saying things, well, I always roll that, you know, this is what I always roll. And if you break it down, it's really not that way. It's just you begin to feel like, wow, I'm always rolling this. And then when you see it, it stands out even more. You're like, oh, see, I told you, I always roll that. When you break down the numbers, it's not the case, really, when you look into this. So let's say I'm trying to roll a 5, okay? Now, how many possible, first let's start there. How many possible outcomes can happen, okay? If I roll a dice, now we are taking out the weird, like, well, it sat up on its side and didn't land on any number. We're taking that out, okay? We're not using that. Because in a game, if you're playing that and that happens, you get to re-roll anyway. So we're not talking about it just sitting up on its side or flipping a quarter and it lands right on the edge. We're talking about getting a number. You're going to roll it and get a number. Well, how many possible outcomes? Well, there's 6. You could roll a 1, or a 2, or a 3, or a 4, or a 5, or a 6. So there's 6 possible outcomes. And then my favorable, now if I'm trying to roll a 5, that does not mean I put a 5 up here. Okay, that does not mean I put a 5 and say 5 out of 6. Because you're not saying I want to roll, because then a 5 out of 6 would be much higher than if you're trying to roll a 1 and that's a 1 out of 6. That's, you have the same chance of rolling a 5 as you do a 1. So that's going to be, if you put a 5 here, that's going to be much higher than if you put a 1 here for the 1. You're saying that you want to roll a 5, which means you got one chance, there's only one 5 on that dice. So you have a 1 out of 6 chance of rolling a 5. Okay? Same thing if you wanted to roll a 4. If you wanted to roll a 4, you have a 1 out of 6 chance. And just like I said earlier, if you tried to roll a 1, you have a 1 out of 6 chance. You have the same chance of rolling a 5 as you do rolling a 1. Okay? It may not seem that way when you're playing. You may be like, I never roll a 1. But you have the exact same chance of rolling a 5 than you do a 1. Okay? Unless the die has been messed with or tampered or, you know, something like that, you have just the exact same amount of chance as rolling 5 as you do a 1. You have a 1 out of 6. Now, to turn that into a percent, we do the same thing as we did on the last test. You just take 1 and divide it by 6. We'll do that on the calculator. Okay. So 1 divided by 6. And it comes to 0.1, and then the 6 keeps repeating. Okay, so that's a decimal. We need to turn that into a percent. So we need to move the decimal twice. And if we're rounding to the nearest percent, okay, we move the decimal twice, it's a 17% chance. Okay, you have a 17% chance of rolling a 5. Okay, that means you have a 17% chance of rolling a 2. You have a 17% chance of rolling a 3, and so on. Okay, it's not a high percentage, but it's also not super low if you're playing a game. Okay, so it's, you have a 1 out of 6. Now, what kind of changes then is if I roll that dice again and I'm trying to get things, okay, the possible outcomes continue to stay the same in that scenario. Now, as you go to different scenarios, like drawing a card, well, now there's 52 cards, this changes. It's not 6 anymore. But let's say I roll that dice, and instead of trying to get a 5, I'm trying to get an even number. Okay, I'm trying to roll an even number. Well, I still have 6 possible outcomes. It still could be a 1, a 2, a 3, a 4, a 5, or 6. I still have 6 possible. But now I'm not just trying to roll a 5, I can roll any even number. Well, what's the even numbers that would mean I win? That's kind of how I think of favorable. If I'm trying to roll an even number, then I want a, an even number, then it's favorable. Well, what even numbers are on a dice of a 6-sided dice? A 2, a 4, or a 6. Meaning if I'm trying to roll an even number, I've got 3 chances to win. I can roll a 2 and win, I can roll a 4 and win, or I can roll a 6 and win. I don't know why I keep pretending I'm rolling a dice, but it just helps. It helps the process. But basically, if I can roll a 2, a 4, or 6 to win, that means I have 3 chances to win. I have 3 favorable outcomes. If it lands on a 2, hey, we're good. If it lands on a 4, we're good. If it lands on a 6, we're good. So that means I have a 3 out of 6 chance to roll an even number. Not a 1 out of 6. Okay, that would be if I'm just trying to roll a 2. Because I'm trying to roll an even number, I have a 3 out of 6. Okay, so a 3 out of 6, if you divide 3 by 6, you get 50%. Even. It just comes out 50. Which if you take that on the flip side, then you have a 50% chance of not rolling an even number. It's either going to be odd or even, so you have a 50% chance. Okay, so that's kind of what you're doing. This didn't change on the scenario because you still can only get 6 numbers, but what changed was up here. Another example is, what if there's we got to look at the possibility of having a 0% chance of something. That'd be like saying, I want to roll the dice and get an 8. Okay, and the dice only has 6 numbers. Well, if I'm trying to get an 8, and there's only 6 possible chances, how many 8s are on the dice? None. 0. There's no 8s on there. So if you divide 0 by 6, you get 0, and therefore you don't have any chance. You have a 0% chance of rolling an 8. Just cannot happen. Okay? So there is those, that can happen in these scenarios. Well, I can't roll an 8. Another example of a 0% chance is to roll like a 3 and a 4 at the same time. Like roll the dice once and you get a 3 and a 4. And that's a big difference of the word and or. Okay? If I say 3 and 4, okay, and 3 or 4, there's a big difference. If I roll that dice and I say I want to roll on that one roll, now I'm not talking about 2 rolls, because that gets into later if we go that far where, what's my chances of rolling this and then picking up the dice and rolling this, one right after the other. We're talking about rolling the dice once and getting a 3 and 4 at the same time. Well, we know that's not possible. It's 6 chances of something, but that's not a possibility. It's a 0 out of 6, a 0%. Now a 3 or 4, that is possible. If I roll the dice, I've got 6 possible chances, and what's the chances of rolling a 3 or a 4? Meaning if I roll a 3, I win, or if I roll a 4, I win. Well, that means I have 2 favorable outcomes. If I roll a 3, it's good. If I roll a 4, it's good. So that's 2 out of 6, which if you divide 2 by 6, should be somewhere around a 34 or 35%, depending on the rounding. Let's do it. 33, oh, a little bit lower because we rounded up the other way. So 33% chance of rolling, oh, yeah, my math brain left for a moment because I should have known 1/3, that's the same as 1/3, so it's 33% chance. Okay, so that is how you would do the favorable over possible. And that can be rolling a dice, that can be drawing a card, that can be anything. Let's look at drawing a card, okay? Because we've done a few of these now. Let's change it, we'll keep the same formula, and let's change it to drawing a card, okay? And if you don't know a deck of cards, I'll try to, put maybe something later of like all the things, but basically, if you know a deck of cards, it helps. You may want to look at a deck of cards or look up a deck of cards and see what what it is. But basically, you have 4 what we call suits. Okay, you have hearts, diamonds, spades, and clubs. And each one has these little symbols that tell them what they are. And then in each one of those suits, you have an ace, which you can consider a 1. You have like a 1, if we call it a 1, a 2, a 3, a 4, a 5, a 6, 7, 8, 9, 10. And then you don't have 11 or anything, but then you have a jack, a queen, and a king. There's basically 13 cards in each suit. Okay, so you have 13 hearts, you have 13 diamonds, you have 13 spades, you have 13 clubs. That means you have 52 cards in a deck. Not counting the jokers, you just have 13 of the cards in each deck, or in each suit. These 2 are red cards, so the hearts and diamonds are red, the spades and clubs are black. Okay, so half your cards are red, half your cards are black. And so then, you get into drawing these cards and you're trying to find the probability. Well, what's the probability? I just said it, but what's the probability of drawing a red card? Well, let's use our thing. If there's 52 cards, okay, and 13 of the hearts, 13 of the diamonds, these are both red, that means there's 26 red cards in the deck. That means if you divide 26 by 52, you get 50%. Half of the cards are red. So you have a 50% chance of drawing a red card. You reach into a deck, you have half of them are red, you got a 50% chance of drawing a red. Same with a black card. You have a 50% chance of drawing it. Okay, now if I get more specific and say, well, what's my chances of drawing a spade? Just a spade. That's half of the black cards are spades, but there's 13 of them. So to reach into a deck and to draw a spade, any number, it could be a king, it could be a 4, but it's got to be a spade. Well, there's 13 spades, so this didn't change. There's still 52 cards, but you had a 13 out of 52 chance of drawing that spade. So if I put that into my calculator, okay, and I do 13 divided by 52, I get a 25% chance. I really need to use my brain at the same time as my calculator. You have 1/4 of a chance, okay? You got a 1/4 of a chance to draw a spade out of that. What about drawing like a 4, okay? Well, there is, how many 4s are in the deck? Well, you have a 4 of hearts, a 4 of diamonds, a 4 of spades, a 4 of clubs. So you have 4 4s, okay? Let's say you want to draw a 6. Well, you've got 4 6s. You have the same chance of drawing a 6 as you do a 4. That doesn't change to a 6. There's not 6 6s. There's only 4. So you're going to take 4 divided by 52, and you get a comes out to 0.0769. Move the decimal twice, and you have a 7.6, which if we're rounding to the nearest percent, it's 8%. Okay, you have an 8% chance of drawing a 6, okay, or a 4. All right, so I'm going to leave it there. I'm going to put a couple up here for you to do, okay, and that's what you're going to turn in your assignment for today. So I want you to find rounding to the nearest percent. Okay, rounding to nearest percent. So you need to turn these into a percent. Don't leave them as a decimal. On a 6-sided die, just like rolling a die, you want to roll a 2. Okay. You want to roll an odd number. Number 3, you want to roll a 5 or 6. Or 6. And I'll highlight or. Number 4, we're going to talk about drawing a card, drawing from a deck of cards. You want to draw a 4. Don't draw a 4 on your assignment like an art picture. We're talking about drawing a 4 from a deck of cards, okay? Drawing a heart. Okay? And the last one, I want you to draw a 7 of diamonds. Find me the probability of drawing a 7 of diamonds. Round to the nearest percent and turn that into your assignment today. Thanks, guys.